This time on KEI Fabrication. Hide all the women and children. Alright folks, what I've done here is I've measured the width of the rear end, and what I really want to do is make sure that the weld, when I cut this and weld it back together, falls where the spring perch is going to go. And I figure the reason why I want to do that is the spring perch, the saddle, when it's welded on, will add to the strength. So what I've done is I've measured where the center of the spring perch is going to be, and then I know that I need to shorten the axle to 2 7/8 inches. So I very carefully measured the width of the cut, and what I've done is I've used a hose clamp here and I've tightened it up and rotated it good so I know it's nice and square to the tube, and I'm going to use it to make a scribe line all the way around. And the reason why I do that is when I'm going to make the cut, I'm going to cut just to the inside of the tube that's going to come off, and then just to the inside of the stationary tube. And what that'll allow me to do is make adjustments to get it all square, so in case the cut was a little crooked, I can fine tune it and grind up to the line to make sure that my 2 7/8 distance is perfect, so when I slide the axle in and the C-clip can drop in and pull it back out, and I've got the appropriate amount of play. So that's my method for doing this. It gives me a nice firm edge to scribe on. I sprayed some bluing dye on there. This is called steel blue. It's a machinist dye or layout fluid. So it gives me a really good contrast between the shiny metal that's underneath the bluing dye. It gives me a good thing to follow when I'm cutting. So what you can see is a really nice crisp scribed line, and this is the section of the tube that I'll be removing. When I make my cut, I'll come just to the inside, as I said, just to the inside. In case I cut a little crooked, I have plenty of material to make sure that I have plenty of material to miss the line, and then to make it all good and square, like I said, I'll grind up to the line. You can see I've prepped the axle tube all the way across, so if I do put a back brace on, I think I'm going to, but I have to engineer it a little bit so I can get U-bolts through the back brace. Try to get all the grinding out of the way that's necessary. I got this side prepped. The spring perch will end up being right here. I've got a scribe line, so the spring perch for this side, the stock side that I'm not cutting, is going to go right there. Alright folks, you can see I've pulled the gear chuck out, and the reason why I do that is I use the Baron caps to put my alignment fixture in. You can see that these pucks I made on my lathe. This one is for the 8.8 rear. What I have here is an 1 3/4 turn, ground, and polish shaft. It's long enough to reach on both sides, so I can narrow or a variety of rear ends, the truck rear ends that are wider. So one thing you want to make sure is when you have the pucks in place, sorry for the heater noise, and you got your Baron caps tight, you want to make sure that the rod moves back and forth, and that way you're not cocking these things and making it way off. So one of the reasons why I wanted to show you this is these are the bushings that'll actually hold on to the axle end. And what I wanted to show you is that all factory rear ends are off. If you can see the gap between here and here, then you can see that there's some overhang here. This is the driver's side axle, and I'll show you the passenger side is off in a different direction but equally. So So the point I wanted to make is all factory rears, if you put an alignment jig in, they're all going to be off some, whether it's from, you know, some sort of road damage, if the vehicle is ever towed and they hook chains on it and pulled down on it on the ramp truck, something to that effect. What I will make sure that's done when all the welding is done and all the spring perches are welded on and all those sorts of things, I will put this in there and I will make sure that this is completely centered. I'll do it with the axle tube that I'm going to cut to make sure that the tube is straight. And what this guarantees is that the axle will be in alignment with the chuck, the bearings in the chuck, and I will try to make it as perfect as I can by shrinking the tube on the side that it needs to pull in. So initially when I set this up, I'll make sure that my axle tube is good and my alignment here for my wheel bearing is good. And then what'll end up happening is I'll actually do the straightening process of the rear after the perches are welded on, any shock brackets, the back brace, anything else that's going on. I'll put the alignment bar back in. I'll put my bearing bushings in, and it'll sit tight inside where the seal and the bearing go, and I should be able to just plunk those right in, and that'll tell me that my axle end and my axle bearing are in just about as perfect of alignment as they can be with the bearings in the center chuck. So this is just a homemade version of like the Mark Williams rear end narrowing jig. I also have the plate to do your measuring from, and I've got lines scribed on here. It bolts onto the thing. You can see I've got an 8.8. It's the center of the 8.8 housing is here, so I'll be able to double check my measurements left to right because I am making this a symmetrical housing instead of an asymmetrical housing. So I made all the stuff myself on the lathe, and I bought the turned, ground, and polished shaft from McMaster Carr. Saved a couple $100 in the process, and I ended up with a nice narrowing fixture. I've got some other, see, I've got 8-inch and 9-inch Ford here, and this is small bearing 8-inch and 9-inch, and this is big bearing 9-inch on the other side. I made these, and this is for a 12-bolt Chevrolet is on the big side for the axle bearing, and then it's actually the passenger car small bearing for the 8.8. This is a Explorer housing that actually uses a bigger axle bearing because of the 31 spline axle, so I'm going to have to make a new one of these out of some aluminum bar stock. Alright folks, one of the last things you have to remember before you cut the rear end apart is you have to make sure that the bearing end is oriented properly. I have the rear end flange that the cover bolts to perfectly aligned at 90 degrees up in the air. It's 90.0, and then I measured the flat here on the axle flange, and it is 4.2 degrees upward towards the rear. And just so I don't forget, I made myself a little diagram, and that little notch is facing forward. So the reason why I have to do this is sometimes you cut these things apart, you don't get back to it for days and days and days, you forget the measurements, so write it down. And then when you weld it back together, you should match all those dimensions, and when you put the brake caliper brackets on, everything should be oriented as the factory had intended. So the reason why it's tilted down is there's probably some pinion angle that has been compensated for to get the caliper bracket at the right angle at the installed height, at the correct ride height of the vehicle. Hide all the women and children. Alright folks, when I cut it, I had about an 1/8 inch generous to the line. So what I'm doing is a technique here. It's called grinding to the line. Some of you are probably fully aware of it, just in case you're not. So what you do is you grind at an angle until you just come up to the line. And then once you get to the line, what you do is you go with a large grinding wheel right to the face of the axle tube, and once you see all of that material disappear, you'll see the edge, the angle disappear all the way up, and this will become a flat surface. Once you've got that done, you pretty much are guaranteed a nice square flat edge all the way around. So I'll do the grinding at an angle all the way around. I'll rotate the rear end so I can do it all the way around, and then the last thing I'll do is take the big 7.5 inch DeWalt wheel and I will start smoothing out the ends until I've got a beautiful flush perpendicular surface from the axle tube to the edge of the axle flange here that I'm going to butt up against. And I'll do the same for the other end of the axle tube, and that will give us a nice cut. And then what I'll do after I'm sure that my length is correct, I'll bevel the edge big time so I can get a good root pass in when I weld it, and then do a finish pass around the outside to get 100% penetration. So I don't know how good this is going to focus, but once you use the face of the wheel on the tube and you grind away the angle that you left behind, you can just see that I've got, I don't know if this will focus, and you have to trust me on it, but I've got just like half the width of the line left all the way around, and I've checked it with a square, and it's pretty darn good. So that technique is actually more accurate than you might think. The secret is when you grind with the face of the wheel, you got to watch the material will get smooth from the inside and work its way to the outside. And once that gets smooth to the outside, as long as you did a good job grinding to the line with that angle, that initial angle, you should have a nice perpendicular cut line here. So I'm just going to double check. I'll roll the rear end, check everything all the way around. This is actually minus the bevel. This is actually square and ready to weld the axle tube on. I just need to repeat this process on the other end of the axle tube, and then I'll be able to put the fixture in, the alignment fixture, and then bevel both edges, tack it, and weld it, and just keep watching so the distortion and the shrinkage doesn't pull the axle tube around. Okay folks, so what I've got here is the two pieces that are going to eventually be welded together, and I hope what you can see there is just with a very little work, and pay attention to that line and the face of the grinder, good grinder control, can really get a nice perpendicular surface for these two things to mate up against. And there's no air gap, so the axle tube won't pull when you weld it. If there's any air gap at all, it'll pull and it'll change the alignment of the axle housing. So the last thing I have to do is put a good bevel on here. I'm going to go 50% of the depth. If anybody was wondering what the wall thickness of a stock 8.8 Explorer reel, I measured it, it's 3/16 of an inch. So anyway, the next step is going to be put the bevel on both the rear end housing side and the axle tube side, and then tack it in 3 places equally spaced so it doesn't pull, and then put a nice root pass in, and then a nice finish pass. Next time on KEI Fabrication.